Good morning. It's been a pleasure to be at Voxxed Thessaloniki. It's been so long since the last time I visited the city, and yesterday I had a walk with some friends, and it was even better than I remembered, but the traffic was pretty awful. But anyway, today my topic is about something I started working on lately, and it's about serverless computing and the rise of nanoservices. And I managed to put two buzzwords in this phrase. So let's see what this thing is all about. But before we start, a few things about me. My name is Paris Polyzos. I'm a senior software engineer at stichiman.gr. I'm currently working on ASP.NET Core, Angular, Elixir, and Azure technologies. I'm also a Microsoft Azure MVP. And also I'm a co-founder of a Greek meetup called Azure Heads that is based in Athens. In this slide, you can find all the different ways you can talk to me, so feel free to do so. So what are we going to talk about today? First of all, we're going to start with the changes, the evolution that has happened in application development, the way we develop applications. Then we're going to talk about what this serverless thing is all about, and focus then on functions, that is the core of serverless programming model, and see some best practices that apply. And finally, we're going to talk about, I'm going to showcase you some demos using Azure Functions. So, let's start. During the last decade, a lot has changed in the way we develop applications. At first, everything was on premises. That means that the software was running in the same building of the person or organization that was utilizing the software. Then, with infrastructure assets, then with cloud, with the advent of the cloud, a lot has changed. And at the beginning, with infrastructure as a service, it was very easy to rent some virtual machines and have someone else worry about them. Then with the platform as a service, we had all the necessary tools that we would deploy the software in a cloud vendor and using small drop-downs in order to put more servers to work for us. And now, with the advent of serverless computing, we focus more on the applications we develop and less on the servers. So, to better demonstrate you this whole evolution, let me introduce you to a friend of mine, Babis. Babis is a developer at a small Greek company who's always loved to build applications. At first, everything he had to do it on premises. So he had to go out, buy some servers, put them together, wire them everything, focus on the power and the operating system that should have the necessary libraries for the applications to run, and wait a couple of days till the application is out to his customers. So he had a lot of questions in his mind. What about backups? He should always monitor and maintain this hardware. So instead of focusing on applications, he focused more on stuff like that, cables and servers and hardware. So with the advent of infrastructure as a service, some of his previous concerns disappeared. And now it was very easy for him to go and rent some virtual machines and put them to work even in minutes than before he had to go out, find a vendor, and buy some stuff. But still, he had a lot of work to do. He had to manage those servers, to patch them, to take backups, and check what packages should his servers have, and then find a way to deploy his applications and what the operating system should be. Then, with the platform as a service, those questions and those concerns about the hardware started to disappear. Now, he had all the necessary tools to deploy his applications to an external provider, to a cloud provider, and put his application faster to his customers. But still, he had a lot of worry about the right size of servers for his business needs, how he can scale his applications, and how many servers will he need. Now, with the serverless computing, he is able to only focus on the applications that he needs to build, to architect this new kind of applications. And now Babis became a lot happier. He managed to save a lot of money for his boss and focus on the things he loved, building applications. So he had a lot of money for a lot of time for himself. And Babis changed and became the vigilante he always wanted. Babis became the Batman. And when his boss asked him, "Why are you using serverless computing?" his answer was straightforward: "Because I'm Batman." But Babis is not Bruce Wayne, and he does not have all his money necessary to buy this crazy stuff. So he sat down with his boss and explained him what is this thing. So in serverless computing, in serverless computing, with serverless computing, we mean about applications that fully or heavily depend on third-party applications, which are run in the cloud and used to manage the software and the server-side logic and the state. His applications also are a piece of code that runs in the cloud and are set up in a way to be executed as a trigger to an event. That means that your code runs in stateless ephemeral containers which containers are triggered by events, and they're ephemeral and they're managed by a third-party provider. And as your code sits and waits for events to be triggered, scalability is not something that Babis has to worry about. It is handled by the cloud provider. But Babis' boss was always happy when he pays the less money he can. And with serverless computing and this micro-billing stuff, you don't have to reserve capacity beforehand. You pay only for when your functions are actually executed. So benefits of serverless computing. With serverless computing, you stop worrying about servers. And you focus more on your applications. Of course, there are servers, because your function, your services, somewhere have to run. But you don't have to worry about them. It's not called serverless because there are no servers. It's called serverless because you care about servers less. And with that, you have reduced dev operations because you don't have to manage your servers and patch them or update them or do some stuff. You still have to worry about having your application up and running, but it's heavily reduced. And with that, you can go to market faster to put the products, your business logic in market faster. So serverless computing is based on functions, and functions are the core programming model of them. Function is the unit of work, is what you care about, is the business logic behind it. It starts, it is executed, and then finishes. And the function always have an input and maybe an output. When you start working with functions, you have to answer 4 simple questions. The first one is, what is that I want to do? What I'm going to do with that? The second one is, what is this event that will trigger my function? The third one is about data. Do I need any additional of them, input or output? And with the fourth one is, what will be the output that my function will produce? So concluding, you can have in mind just a simple phrase. That is that when something happens, get this and this, do that, and output something. And with functions, you have a lot of best practices to follow. The best one are the following: that your function should always do one and only one thing. And this is why we call that we are in an area in the rise of nanoservices, because now we have services that consist of a single function that performs a single task. Second one is that your function should be idempotent. And what do we mean with that is that your functions should have the same results with the same input. Consider the following. You have a function that is creating a record in a database. No matter how many times this is, if this function is called more than once, you will end up with the same amount of records in your database. But when your function is triggered, is performing an update to a record in the database, then if your function in the same database, then you will end up with the same result. So a function is idempotent if it creates the same result no matter how many times it is executed. And the third one is that your function should always finish as quickly as possible. You don't need to wait for a function to run 30 minutes and have a crash at the 25th. And then you have to wait another 25 minutes to get the error done. So keep your functions fast, and if the task is quite big, split it in simpler ones and put them to run in parallel. Okay, I'm totally into serverless computing. What can I do? There are currently 4 vendors for serverless computing offerings. The first one, and the oldest one, is the AWS Lambda. And what we mean by oldest one in cloud terms, it's that it started on 2014. Now we have also the Azure with Azure Functions, Logic Apps, and Event Grid. Google also has its offering with Google Cloud Functions. And also it is IBM's Cloud Functions that is based on Apache's OpenWhisk. So let's see what it is, an Azure function. An Azure function consists mainly of 2 things. The first one is the code that runs your logic. The second one are the events that will trigger your function and the data that may be used for your function. So mixing them together, you'll end up with an Azure function. An Azure function, with Azure functions, you can write in multiple languages, the ones you like. Either it is C#, Node.js, Python, Java, Java, and you'll be amazed about the similarities that also exist with Azure functions and all other cloud vendors. You can very easily schedule event-driven tasks. It is very easy to create HTTP API endpoints, listen to webhooks, and create proxies to mix services together. As in serverless computing in general, the same applies to Azure functions, that you pay only when your function is executed. You can have a function wait there for a month and pay nothing, and when there is hype about it, then you start paying for this. And it's very easily, and scalability is not also something that you have to worry about. Throw some events, and the same amount of times your Azure function will be executed. It will be handled automatically by the cloud, by Azure. Another thing is that Azure functions are also open source. You can find a lot of things in GitHub, from the SDK to the tools that is using, so you can get your hands on and see how this thing works. In this table, you can see, hope so, all the different ways you can trigger a function and do the bindings with them. You can easily create a timer and schedule your function every couple of minutes or every hour or so. Consider a task of having to back up some server data. You can create a function that takes those data and perform an operation, put them in an Azure storage account. You can create HTTP REST APIs or listen to webhooks. Consider you are a mobile app developer and you want to build some CRUD operations in a database that is used as a service. So you can have a function that that gives you the CRUD operations. Also, you can create an Azure function can also be called when something changes in your Azure storage account. For example, Anna, if you have an image uploaded to your storage account, then the function will be triggered. And this also applies to queue messages, even either at the Azure Storage or Service Bus. You can connect your SQL databases or Cosmos DBs very easily, and you can also connect your Azure functions in external services, like, for example, Twilio to send the SMS messages, or SendGrid to send emails. But also in experimental, currently in preview, you can also connect other services like Google Docs, OneDrive, Dropbox, so you can create a lot of things mixing services together. So, what a function looks like. In this slide, you can see two files. The first one is the run.csx, where it is the code that your function needs to do. You can see that your function is called when a new stream, a new image is uploaded to your Azure storage account. You can get some bindings from that image, for example, the name and the extension of the name. And then you can also output the scaled image at another area of your storage account. So you type with 10 very simple code lines, you can perform a task, and when you upload an image, you can create multiple scaled versions of it. In the second file, with the function JSON, you declare the bindings of your services. There is an array of bindings, and the first object describes the input that the trigger that fires your function, and some bindings on them. So you can see that if an image is uploaded to image to resize folder, then your function will be called, and the output, which is declared at the second binding JSON, will be saved at the images resized folder with a different name. So let's start with some demos in order to understand what this thing is all about. Okay, the first thing that you can do is log into an Azure portal. But if you don't have an Azure portal, if you don't have an Azure account and want just to try these things, you can type "try Azure functions" in Google and get to the first URL where you can start working on a function. But let's move on to the Azure portal to see some things here. Azure portal is mainly split in three areas. The one at the left is where your services, where your favorite services are, because there are a lot other. No, I can't find it. Okay, where your services are, your favorites one. At the top bar, you can see the notifications and the search text field, where you can easily search where you're to find your resources, and some other stuff about your account and some settings. At the center, there is the main dashboard where you can pin shortcuts to the service that you want to use. So here I have created a serverless demo function, but let's see beforehand how you can create a new one by yourself. When you click on the new button, you can go to the compute area here and select the function app. Then you have to give a name that should be unique. For example, functions Voxxed days. Select the subscription that you want to use and check if you want to create a new resource group. A resource group is a type of thing that groups services together. Select the operating system that your function app should be based on. The hosting plan, where you want your function to be triggered as an event, or when an event happens, and not running continuously. The location that your function should be, select a location, a region that is close to you, and then a storage account where the logging will be saved. And now you can create a new function app. So we don't have to wait for one to be created. So let's start with the one that I have already created, and we're going to use Slack in order to see how this thing works. First of all, I have created a webhook here, a simple greeting, where I can send a message to my function and get a response to that. So if I type something here like hello, okay, I get a message that says greetings and is everything good, fine. So okay, the first one used works. And let's see how this is all set up. I have a small function here that is written in Node.js, where I have some words, some keywords, and when these are triggered, I get a response back. Here the area is that I have this, the functions that I'm using. At the center area is the code that I can write or I can type on. Down below are the logs from the operations that have happened. See here that I've sent a message and it responded. I can clear, and at the right side I can upload my files or create the index.js and the function.js, which describes the bindings behind them. And also I have the option to test my function by now it's okay. So I have a message, and I can test my function right like that. Here is a UI where I can make the integrations between the things that I want. So I say that my function is triggered by an HTTP post request, and the output is also a response request. So I also can manage the state of my function if it is enabled or disabled, and then I can also monitor my function to see some logging about how it is executed. So the last one, and I get all the details necessary for what has happened during the last call. So to better mix more functions together, we can send a message that to request the weather in a place. So if I type weather in Thessaloniki, Greece, let's hope it works. Okay, what has happened here? My request has been processed about the weather in Thessaloniki. I have a function that goes and checks out the weather using AccuWeather API, and I have the Google Maps to grab a photo of Thessaloniki, and then search with another services with Google to get a random image about Thessaloniki. So if I type weather in Athens, for example, I'll get something else. You may notice here that the result is not always in the same order, because I have splitted the way that this works in several functions. So my functions communicate together with messages in a queue. So the first function that takes a message goes grab a photo, and the other one takes the message and finds the maps at Google. And the other function goes and get the temperature from the location I have requested. The second demo will be about using logic apps. The logic apps are another serverless offering, for example, that allows you to mix multiple services together as a workflow. So I have created a small logic app where I search every 3 hours the tweets about Vox days. And for each operation, I have created a condition that if the tweet is in English, then I detect the sentiment about how the person that wrote this tweet feels about. So I detect the sentiment of this tweet, and I'm using a cognitive service on that. Then that gives me a score. The score is a number between 0 and 1, and the more happy a person is, the closer to 1 it is his answer. The less happy, closer to 0. So I have a function that performs a very simple task to get this score and categorize it, giving me a color, green, yellow, or red, based on how the user felt. And then in order to visualize what has happened, I have a Power BI service that I put all these tweets in a map and have a look around how the person is feeling about that. So this is the end result here, where I can zoom in and see that there are some how many results from what location, how this person feels about, and also if and also I can get the first tweets that shows what this person has told. Okay, so give it a minute for this to power up. Okay. Till this begins, we can see how this categorize sentiment function is. It's very simple. Okay, so you get a value of green if it is more than 0.6. If it is less than 0.3, it's red, and if it's is between 0.3 and 0.6, it's a yellow color. So here, wow, they're very big. It's pretty difficult without a mouse. So here we can also see what this guy has done, has said in this in his tweet, and we'll try to find out how he feels about it. And the last demo is about creating mosaic pictures. I'm going here. Okay, I have built an application here that is called Function App Mosaic, where I load from a single static HTML that I can go and upload a photo from a landmark, from a place I want. In this, we're going to select something from Thessaloniki, so I can get an image to be something like this one. Downloads. This one was Okay, let me find it. Okay, I will upload it. And till this happens, what is going behind the screen, behind the scenes is that I have trained the model using custom vision and analyzed the image in order to detect that this photo comes from, has the White Tower inside it, and understand that this thing is from Thessaloniki, and then go and search the web for images related to Thessaloniki and create a mosaic from all other services that you may see here. There are other images from Thessaloniki, like Voxxed, I think it's here, and other images from Thessaloniki. I don't think you can show it correctly, but it's the best. Then okay, in order to do so, I have used the service here that is called Custom Vision to do so, and I put some images from Thessaloniki. This is the Bougachan that I would like to taste after the session, and from Acropolis or from Sen to better understand, and I can tag them to understand which are related to Thessaloniki, and I get a mix of them, of all these functions, and put them together. One of the difficult things with with functions in general in serverless computing is that usually most of people have this portal to work around, and tools when we try to build more serious apps are necessary. So in the last part, I would like to show you that the same thing that has run in the cloud using this kind of web editor can be done also in using .NET Core inside in the Mac. So I will start with funchost start. Okay, here's the ASCII art that my service, my Azure function is going to work. The code is something like that on above, where you can see that I am tagging. I'm giving a name to my function and write C# code as I used to write. And here I think it will, okay, get it live and select some images on that. Put in level. That one. So here at the logging you see that it got the location, analyzed it, and find out that it is related to White Tower. Query the internet and find all other images related to Azure storage, related to Thessaloniki, get them together and put them in a mosaic and have it run here. And the same thing applies, and what we told before about scalability is that it's not something that we have to care about, because I'm now throwing a lot more images on that. It will trigger and eventually it will generate the same output for all these results. So okay, the one was okay. So concluding, nothing. Let's see, not here. Here is the structure of the Mosaic application, that you have another storage account where you just put an HTML file in there and have a proxy in another function that that takes this content to serve it, and two requests that listens to request Mosaic, to API request Mosaic, and settings, that API settings, which are two functions, where you get your final result. So, as an overview and some things to remember. Serverless computing is quite awesome when you start working on it. It has some limitations but you can create a lot of things, especially if you are building applications that respond to events. It's amazing in general how the similarities between all cloud vendors. So you can try the one you like, either it is an AWS account, an AWS, Google, or IBM's. It mainly has the same also UI, so you don't have any. You will get accommodated very easily. There are a lot of limitations at the moment, and some vendor lock-in that if you started working with Azure, for example, you will stick to that because you combine all you using the other services that the provider is using. And the final thing is that it's all about the cost. It's not that the tech behind serverless that makes it so great, but it's the financial incentives that you have a function that sits in the cloud and waits for a request, and then you get billed. I think, for example, if you have a ticket service and you want to give 7,000 tickets, your applications will have a hype for about 2 hours, 3, and then it will sit down and wait for some request. In serverless, you don't have to pay anything about that. So, thank you all for being here. I hope you enjoyed the session so far. That's it.
Thank you very much.